a static page, and then in the backend there is an app logic. So if it's a simple app, then you would have an app logic, and then app would be talking to the database as needed.
Or yeah, great. So perfect. So yeah, what should we cover this time so that it should be helpful for you in the interviews? What's the very next interview, or what's
maybe one system design question will still help.
Okay.
What I'm thinking is, Tarun, my thought process on system design is this: that there'll be a front end, and that is let's call it the the web server, and
Yeah.
that is the one that provides provides the front page.
Yes.
Most likely a static page, and then in the backend there is an app logic. So if it's a simple app, then you would have an app logic, and then app would be talking to the database as needed. Now,
Yes.
let's say if the load on the app, there could be mechanisms where we want to separate the app into multiple pieces. For instance, if I take a case of Dropbox, then app may have one part which actually is writing the metadata, and another part which is syncing.
Yes.
So that could be one. On the other hand, the in terms of database, I have choices like SQL, NoSQL.
Yes.
I have, and if I do SQL, then I'll need to take care of partitioning.
Yes.
Whereas if it is NoSQL, then that is typically taken care on its own. So so for NoSQL, the basic question that I have, so okay, before I go there, so NoSQL, so we have choices of going to SQL or NoSQL, and
Yes.
really depends. If we are mostly okay with eventual consistency, then we can go with NoSQL. If you're looking at scaling, right now, the other thing is,
Yes.
would we still need consistent hashing in NoSQL, or consistent hashing is mostly an SQL related concept?
No, consistent hashing is required. Hashing you also use for load balancing as well. So could be
But
there.
that is another question I have. So why do we need to, if we have a scaled system, when the requests come, does the server, the MySQL server, whichever the broker or whatever, in case of say, if there is a PubSub, Kafka and other things, right? There is, sorry, I'm mixing up. Sorry. No, for NoSQL, it is MongoDB or Cassandra or one of them. So for them, they'll be again they run as a server anyway. I mean, it's the what you interact when you interact with the SQL, NoSQL. Typically, you interact with the server. So and we say that server can scale horizontally. So which means that when we give anything, then would the server automatically scale? And that is a basic question. I mean, what I'm thinking is, let's discuss about some of these components rather than.
Yes, sure. Yeah, definitely. See, what actually happens is in Amazon, there's something called elastic cloud compute, right?
Yeah.
So
Okay.
I'll give you an example, or similar concept is there in Azure as well. So what you do, so assume you have created an application, which is say tiny URL application. Let's take an example. And now you have millions of users, so you would like to have multiple servers, and your application is in multiple geographies as well. So you will ensure redundancy, you will have different availability zones, and we talk about, assume, say for India, you see that, okay, there's a lot of servers needed. So in EC2, what you will do is you will create server instances. So assume you have done this app in Node.js. So you would create a server instance, which will be much virtual machine, and that will be running Node.js, right? And while you will be instantiating this server instance, you will give some parameters that ensure this is 500 milliseconds response time, and it should automatically scale. So there is an auto scale feature in Amazon EC2 Cloud, in which you can say allocate up to 100 servers for this particular server which you have created. So what will happen in case there are a number of requests coming to the server? The Amazon will automatically instantiate that many instances. So generally, your hardware, any application which you deploy in cloud is scalable, horizontally scalable, but you will give a limit, because also sometimes not recommended to use such, because in case your site goes viral, then you will get thousands of dollars of bill from Amazon, because Amazon will charge you for that amount. So you put a limit actually that scale from say 10 systems and up to 50 systems. So you will put that scale. And automatically in Amazon, they have this facility in the infrastructure that as number of response requests are more, to balance the load, it will create more instances.
Yeah, okay.
So this is the first part.
Yeah, that's the first part. Even there, do you have to specifically do some sort of DNS mapping or something, or meaning, do I only have to worry about instantiating my application in EC? I have actually run EC2
Yes.
application in EC2, so I know. But is it only a matter of instantiating my application in EC2 and indicating to Amazon that I would want to auto scale this automatically, or do I need to actually manage this? By the way, this is more a question related to cloud, Amazon and cloud providers, right? But let's talk about this, and then I'll ask you other questions.
Sure. So so first thing is instantiating your hardware. So this is about the server. Similarly, you will choose your database as well, right? So
no. You go. My question is, does auto scaling happen just by stating that you want auto scaling, or
Yes.
you need to really do something to make auto scaling happen?
No, you just have to. No, it's just you have to specify. So while instantiating, you have to just put the appropriate configuration so that the auto scaling happens.
Where do you have to put the configuration in EC2?
When you create in the interface in the UI in the cloud console itself, when you instantiate, you will choose what kind of server you would want, because it will ask you whether you want a medium-sized server or a
correct. It asks that, yeah.
So you choose that, and it's part of that creation wizard itself. So you will choose what is the zone. You will choose.
No, all that is correct, but I've not seen scaling there. That's why I'm asking.
Scaling is also there.
Okay.
Yes, maybe. Yeah. I need to also recall, but yes, that's the only way. 2 years back, 3 years back, you do that scaling. So nothing more. And if so, I remember there is an option. Do you want auto scaling or you don't want auto scaling? So generally, best practice is we don't enable auto scaling, because you want to keep the cost in control. Right? Because yes, so that's why generally most of the developers, they'll keep auto scaling off. But I think in production, you have to do auto scaling on, because if your application is very critical and you don't want to let your customers wait or see bad performance, so you will not. So companies like Dropbox or companies like Pinterest, these companies also run on AWS. They will use this auto scaling because probably they will be very big companies, and they will not bother about money too much. But at OYO, we used to have that best practice that don't turn on the auto scaling. Generally, for internal applications, we'll turn it off so that you save cost. Otherwise, in few hours you can get thousands of dollars of bill.
Okay.
Right, because also, so that's one way. The other way is through the infrastructure script as well. You can. So what actually?
No, but okay, Tarun, I'll stop you here. The reason is because my question was slightly different. See, you are referring to how you scale in a cloud. What I'm asking is, in general, how do you scale? What is the concept
Right.
for?
Correct.
So one is load balancing. So horizontal. See, there has to be an infrastructure which actually spawns off these machines
Yes.
and distributes the load. That's why you will have a load balancer in front, right?
Yes.
So you will have a load balancer, and behind load balancer you will have a list of servers, set of servers.
Yes.
But that is one part. My question is, let's say, so from a app perspective, we can have a load balancer. That load balancer can have a set of
Right.
servers. Now those set of servers are now accessing SQL or NoSQL, right?
Yes.
So in case they are accessing SQL, my understanding is I will have to manage where my requests go.
Okay.
Right?
Okay.
I'll have to do partitioning.
I'm going
There is-
to, yes,
yeah.
go detail. So let me talk about. So this is your application. So you have created a Node.js server. Now you want auto scaling, because if you do auto scaling, your application logic should also be supporting auto scaling, right?
Mhm.
Because if you have some say variable or hard coded value which is you are using reading it from a particular server, then it's not scalable, because what is most important criteria for your app design is it should be stateless application.
Yes.
Your application should not be stateful. If you have a stateful, then whether you put no load balancer or whether you put auto scaling, your application will not behave properly. Because if you have a stateful application, your state is stored in a particular server. In that case, you have to get the same user to the same server, right? So now you were talking earlier about consistent hashing, right?
No. So before you go there, so what you said is that my application has to be written in such a way that it is stateless. It doesn't have too much. It doesn't have any dependence on any state. Only
Correct. Correct.
that's when I'll be able to do auto scaling or
Yes.
scale
Yes.
horizontally.
Yes. So
Okay,
now
so
take an example of some app where you log in. Now, when you log in, the server gives you the token, right? Session ID. Token or session ID. So this is something which is stateful, right? If you store this session ID within your application server, then this becomes stateful. To make it stateless, what you have to do, any information which you are storing in your server, you need to store it in the database. So the first rule, which is very important of system architecture, is do not store anything on your application server. Store everything on the database.
Okay.
Then it will become stateless. Now,
because anybody can query and get the same state.
Yes.
But what do you do with SSO, single sign-on and all that?
Yes. Okay. So now in case of single sign-on, you don't use the database to store your username and password. You use always a separate infrastructure for storing username and password. There are two reasons. One is scalability, because this database you would like to query and it should be fast, because login should be very fast, right? So you move it into a separate database. Other reason is security. In case your database is compromised, someone gets to know about your database, then he should not get to know about your username and password. So you create a very secure storage for username and password, and LDAP or Active Directory. These are the database. They are just like a key value pair. These are the infrastructures which are used for storing username and password. Right? So
Tarun, 1 minute.
Yes.
to be persistent on the server, but you don't want access for don't want to give access to others.
Yeah.
You don't want to have any sort of
Yeah,
conflict.
you read, yes, only provide access for authentication purpose. Yes.
Yeah. Typically, you use JWT, right, for this?
JWT, yes, is the JSON Web Token
Huh.
is part of OAuth protocol. So this is one implementation of SSO. So now what you need to do is, so when you talk about SSO means you log in one server, but you may have hundreds of applications, right? So even you have just logged into any of one application, the session should be valid for all other application within your enterprise. So that is SSO.
Correct. So that is stateful, right?
Okay. Your token, no, this is again, you can do this in a stateless manner, right?
Okay.
Because, no, as I told, the difference between stateless and stateful is if you have a common storage of information, this is stateless, right? Since you are centrally storing the token is not available in any of the server. It's not specific to any server. It's available to everyone. Is it? It is stateless.
Oh, it's stateless, is it?
Yes. Actually, without SSO, it will be stateful, right? Assume you have, say, Gmail, and you log in.
You're breaking off. 1 minute. I can't hear you.
Okay. Just a minute.
Yeah.
Also use some microphone. Just a minute.
No, this is better. Now we are okay. Yeah.
Okay, maybe some temporary glitch, but just a minute. This will sound really good. Okay, great. So when you have a single application, say, you have a timesheet application in your organization. Now, this is a stateful application in the sense that if you log into timesheet application and then later you want to access your payroll application, your token is only valid for this particular application, which is your timesheet application, right? Now, when you make this single sign-on, what you do is when you will log in, right? You will have a token which will be generated, and then to all your applications, you will say that if this timesheet application authorizes an application, you also trust this application. So generally what you do in the background is you have a server certificate and you create trusted servers saying that who can use this authentication, because no other security problem is I authenticate in my timesheet application, for example, and if someone knows that, okay, if token is there from timesheet, then some other application may want to use the same token and would like to, maybe even a third-party application, if they get the token, they will also authorize that particular user, right? So this is a security flaw. Now, the token is encrypted in using the JWT format. So there you have, whenever someone authorizes, there's an encrypted token which is generated, which will contain what all authorizations or role a particular user has. So that detail is sent in JWT token, which will be sent in the, with all the HTTP request.
So this is actually sent in the authorization header.
Header, yes, it will come in the header, and yes.
It's known as bearer, I think. Bearer is the.
Yes, bearer token. There are two types of token. One is the access token, as other is the bearer token, right? So first what you do is you onboard. So as you assume in
Tarun, you're breaking. I can't hear you.
Okay, sure. I'll go slow. So assume you have Azure. Azure Active Directory, right? As your for SSO. This is your authentication, auth, and okay, authorization, authentication. Uh, so, so again, yeah, there are various concepts because you can have all your
No,
users.
but one basic question again. Maybe I just want to come
Yes.
to the main point.
Yes.
So the basic question is, JWT or SSO is it stateless or stateful?
Is it stateless?
It is stateless, is it? Why is it stateless?
Yes.
Because you're not tying it to a specific server, is it?
Yes. So your application. Okay. Yeah. This is, I would say. See, once so what you do is any API you call, that API will look into the JWT token header, correct? And only if it is having the authorization, it will process the request. Correct. So yes, this makes this stateless because although you have authenticated, but until unless you don't provide the header with the right information, you will not be granted access to any of the API. Yes, so it's completely stateless because some state is there, but state is there in the database and which is available across all your instances. If you have to request to make a call, go to a single server, then only your application is stateful. Okay, so an example of a stateful application would be, say, assume you have an application where you are storing a shopping cart, and somehow, when you make a call, you log in and then you get a cart, and when you add items, these items are stored locally in a server, right? So earlier, many applications, what they used to do is...
You're breaking. Tarun, you're breaking.
Okay. So what... Let me see my connection. Is that the problem with the connection or... Okay, so I have moved, I switched the network. Hopefully it should be faster or better. Okay. So yeah, I was talking about earlier, a lot of applications used to be designed in a way that if they store any shopping cart kind of application, the data is stored on a particular server only.
Okay.
That was how monolith application used to be designed.
Okay.
So in that case also you can have load balancers, but you have to ensure that if I am served by server 1, then in case after some time I make another call, I should be served by server 1 only, because otherwise I'll lose my shopping cart. And in case that server crashes, I lose my session, right? So sometimes you might have noticed you are booking IRTC ticket and you have selected everything, and just you are about to do the payment, something crashed and you lose all whatever you have entered, right? Because that was a stateless server, maybe because of the load, it went down, and when it came back, you lose your information, or you were maybe redirected to some other server. So then this is not scalable. But that you have never, that you don't see nowadays in Facebook or in Amazon, because it's completely stateless application. Because their server still crashes in Amazon, in Facebook, but if it crashes, you are served by some other server, right? And the cache, so your information will be stored in in-memory cache, and which is common, which is centralized, so that any server can access that cache, right?
Okay.
So that's the concept of stateless and stateful applications. So this is very fundamental concept, because if you want to convert an existing application to scalable, horizontally scalable application, then the first thing which you need to ensure is your application should be stateless. So when you are talked about so I would suggest you to use the word stateless in any of the system design question, right? So if I ask you, okay, design a e-commerce application, or I ask you design a hotel booking application or any kind of application, first thing you should say, okay, I'll design it in a stateless manner, right? And because it has to serve millions of users, and I would use a number of servers, and requests should be served in any of the server. So I'll design it in the stateless manner. So that's first concept. Then the second thing is microservices, so which you would be knowing about. And then coming to NoSQL and SQL database, I would say that always use NoSQL databases. So only if you have to do financial transaction, then only you need SQL databases. So this is other rule I will say, that whatever question, if you have non-financial data, use NoSQL databases only.
Okay, no, that's fine. Okay, now assume that I put
Sure.
a NoSQL database or a SQL database. So see, one thing is that I think we touched upon this, but load balancing.
Yes.
From load balancing perspective, load balancing will use one of the techniques. It may be hashing, it may be partitioning, something it would do, right? To
Yes.
load balance.
Yes. Yeah. So very important is you should also know what are various routing algorithms or load balancing algorithms that you can apply in load balancer. So first thing is round robin approach. Okay. Just a minute. Let me switch on my fan.
Yes. Yes.
नहीं रिकॉर्ड हो रही है
Able to hear me properly?
Yeah, I'm able to.
Okay. Oh, sorry. I forgot to unmute. I was speaking, but yes. So you were talking about the load balancer, right?
Yeah. So you said there are standard techniques, round robin and all that. That's
Yes. So for round robin, I was saying that it has a serious drawback. Is not used generally round robin.
No, that I understand. Then there is weighted round robin, right?
Yeah. Oh, okay. You were able to
weighted
hear.
round
Okay,
robin.
great.
Okay.
Yes. So weighted round robin. This is most common because your servers are different. Now, other techniques are, so yeah, basically you can assign priorities, weighted round robin, then you can, based on the response time from each of the servers, you can do, or you can apply hashing on the IP address of the caller, right? So whenever you get a request, what you can do is you can take the hash of the IP address from which the call is coming, and then accordingly you can distribute your calls. So these are various load balancing techniques.
I'm just noting down, okay, as we speak. You will hear some sound, but
Sure.
Yeah, I had actually Educative also has this round robin, weighted round robin, hashing. So okay, so we discussed about load balancing. Now let's say the load balancing is done, right? So let's say there is a specific case where multiple requests are coming. Will those requests first land in a queue and then go to the load balancer, or they'll come to the load balancer and then go to the queue?
Yes. No. So you don't use any queue to load balancer. Load balancer is your just first machine which is hit just after the firewall. So you may have a firewall or a reverse proxy, and then you have a load balancer. And you usually have only one load balancer. load balancer do not do anything. It will take the request and it will pass it on to the appropriate server based on the load balancing algorithm, right? So load balancer is very lightweight application or no system. It do two things. One is it keeps pinging all the servers because it needs to know how many servers are available or are active at the moment. And then whenever a request comes, it passes to the appropriate server. So since this is a very lightweight process, usually a load balancer can take millions of requests per second. Because you don't have any logic, and it's not as advisable to put any logic because you want this to be as fast as possible. And at max, what you will have is you may have 2 load balancers, because in case the hardware failure happen in load balancer, then you have another one just for high availability scenario, in case there is a crash, so you can recover using the other one. So just one load balancer. One is the active one and other one may be for disaster recovery. So you can note down these terms. Talk about, whenever you are talking about load balancer, so you can say, okay, it's a lightweight system and it does only 2 things. One is the availability check, other one is routing the request. And you keep one as your active load balancer